Well, hi, everyone. Happy Friday, and welcome to the Translational Research and Radiology webinar. My name is Gary Boas. I'm a writer with the Mass General Department of Radiology and the hospital's Advances in Motion news platform. And I'm also your humble, affable host for today. Just a quick note before we get started. We'll open the floor to questions at the end of the session. If you have questions at any point, please just drop them into the Q&A window and we will get to them at the end. Okay, so I'm delighted to introduce our two rock star guests today, Matt Rosen and Susie Huang. Matt is the director of the low field MRI and hyperpolarized media laboratory at the Martinos Center for Biomedical Imaging. He's a physicist, a tool builder, and an inventor, and one of the center's mad scientist types. His many successes include foundational work underpinning the recent introduction of the hyperfine portable MRI scanner, which we will cover today. Susie is a board certified neuroradiologist and a physician scientist, also working in the Martinos Center. She specializes in the development and translation of novel MRI techniques for investigations of structure, function, and pathology in the brain. And notably, for the past several years, she and colleagues have led the Connectome 2.0 project, developing a next generation human MRI scanner for comprehensive studies of structural connections within the human brain. All right, so I'm going to hand the proverbial mic over to Matt and Susie, but I'll get things started just with a two-part question for Susie. First, we know, of course, that clinical relevance is a fundamental concern in translational research. But what do we actually mean when we say clinical relevance? And also, since we're talking in part about Matt's work with portable MRI scanners, what does it mean for portable MRI to be clinically relevant and not just a super cool feat of physics and engineering? I will turn it over to you.
Yeah, thanks so much, Gary. It's really fun to be part of this conversation today, and I want to thank the organizers for inviting me and Matt to just chat and talk about our views. So yeah, in terms of what do we mean by clinical relevance generally, I mean, I'd say clinical relevance basically spans that whole spectrum of, say, tools and techniques that we use every day to help, diagnose, manage, treat patients. But I would also include in that spectrum science that's trying to help us better understand what's going on, everything from disease pathophysiology to stratification of patients for various treatments. And I guess in radiology, since this is our research webinar focused more on imaging today, it would span the gamut from tools that we already use, hardware, software, analysis methods, and then things in the pipeline. So to me, portable MRI to some degree already is clinically relevant. We're using it. We're using it in the neuro ICU and then in the ED also. I just learned about that system. So yeah, it's clinically relevant. I guess the question is where along this sort of spectrum do we eventually see it falling, and yeah, like where is it going to go in terms of driving forward the innovation and use of these novel MRI techniques? Yeah, so yeah, actually, Matt, I was really curious in terms of the portable MRI, what your overall sort of goals at the outset were when you sort of envisioned the whole product and idea, and how it sort of met up to your expectations.
That's a really interesting question. So again, thank you to organizers, and thank you, Susie, for spending some time with me. I haven't seen you in a while, so it's great to catch up. So I've been doing low field MRI for around 10 years for different reasons. I was studying hyperpolarized gas imaging in the lungs. And I built a low field system with my student back at Harvard in the physics department to look at inhaled hyperpolarized helium and image subjects laying down and standing up to understand the gravitational dependence of the heart-lung system. And that was work that NASA was really interested in. When I came to the center in 2009, I applied for a grant from the Army. They were really interested in, are there ways we could add this amazing, gold standard of non-invasive neuroimaging to theater, right? So they have, war fighters who have been concussed, maybe what we might call mild TBI, so closed head TBI, could you do some sort of non-invasive tomographic neurological examination in the presence of, what may be shrapnel, right? And so it was very clear to everybody that if you want to do MRI in theater, or outside, more generally outside the controlled access environment of the radiology, MR suite, it had to be at low field. And so, I hadn't done a lot of proton imaging before. I'd done hyperpolarized imaging, which is very, very easy because you have signal way above the thermal level, even for gases. But proton imaging was really hard. And so that, I think the story of portable low field MRI starts there with me at the Martinos Center, being able to interact with the people who, like you, like Larry Wald, like Thomas Witzel, like all the people who are like pushing the technology at the highest levels for, let's call it conventional MRI, to be more sensitive, more useful in the clinic. And so for me, then I had, the development of it is interesting because I treated it as a physics problem, right? Deconstructing everything, looking at all the systems, like what do we keep, what do we get rid of, where do we innovate, how do we use compute? But all the time, I think the thing that kept me and my group from getting sort of stuck developing like, oh, we're going to just develop one little sequence for 10 years, is that we were very motivated by, in that case, military medical docs, interventionalists, neurointensivists, neurologists, to make a thing that in the short term could advise treatment. And so that like constant eye towards clinical applicability, and conversations with people like you and other radiologists and neurologists kept us, I guess, authentic, and not just like a physicist fooling around in the lab. I've been a physicist fooling around in labs for a long time, thinking I was doing medical things. And it wasn't until I came to the center that I realized, like, well, there's an important feedback loop, which happens if we ask people like you, okay, Susie, if you're trying to diagnose a bleed, what's your minimum resolution? What matters? Oh, contrast. What contrast matters? How quick does the acquisition have to be? And it really kept us honest, and it kept us kind of forward thinking. So that of course led to founding Hyperfine in 2014 to really commercialize advances that we developed here in the laboratory and turn it into a real product.
Yeah, no, that's really awesome. I mean, I think you've touched upon so many different themes here in sort of your story and the evolution. Definitely, I think at the crux of the translation is these types of conversations. It's actually very funny to hear you talk about sort of physicists working in isolation, trying to target a problem that they don't know a lot about. And I'd say, like I've also gone through that whole evolution, having done my PhD to begin with in physical chemistry. So it's kind of come full circle. I guess in terms of the sort of translational pathway, what have you found most rewarding about working with clinicians, and what do you also feel is most challenging, I guess, in terms of those conversations?
Right. So doing the second part first, the challenging part is the language, right? I don't know neuroanatomy. Maybe I know a little more neuroanatomy than I did when I came here, but I don't know those things. And there's reasons I didn't go into medicine, in part because I can't remember anything that I can't derive. So finding common ground, as sort of a humorous anecdote, when I started working with Cenk Ayada on oxidative stress, he would say ipsilateral and contralateral to me. And it like sounds awesome, but I had no idea what it was. Of course, it's very obvious, same side and opposite side. So language is I think the hardest thing. And then sort of underneath language, of course, is like trying to deconstruct, like, again, related to language. Okay, oxidative stress, to pick on oxidative stress. What exactly is that? There's biophysics there, there's physical chemistry there, there's physics. Once we get to a place where then I can understand it, then we can run with it. And that's really, I think, the value of having a multifaceted team. So like in my group, I don't just hire physicists. We have, biomedical engineers, chemists, we have all sorts of, disciplines represented in our group. And that's, again, I think, as a way to, like, when we see an idea presented, say, in a seminar or with a clinician scientist colleague of ours, it's the tools we use to capture that idea, grab it, and then see what's in there. And we say, oh yeah, we can't do this. We'll let this idea fly away. Or, oh yes, between our overlapping skills, we understand the germ of an idea that might help. The most rewarding part, of course, is actually doing it. It's really just incredible to see things help change patient care, understanding of biological processes and systems, and ultimately, improve people's lives. And that's the portable MRI story from my group is the first taste I had of that, which was, we could work on something in the laboratory until, okay, now it's ready for like real prime time deep engineering. And then that's spun off where again, people who have deep expertise and those kind of things can go work on it. And then you see the results, right? That's just incredibly rewarding. It's one thing, to publish 5 papers in Phys Rev, and that helps my H index. And we do that, we do those kind of things. But it's another thing to hear from like a fellow, clinician scientist. Oh, wow, this idea really helped these people. So that's really why I'm here. And that's why I think translation is challenging, but it really rewarding.
Yeah, and actually, I wanted to sort of go off that point and put forward maybe like a slightly provocative take on it. So what happens when a clinician, say a radiologist, looks at the hyperfine images and tells you they don't look very good?
Right. Yeah, that's a great.
And how do you react to that? Because I think that's actually maybe one of the huge challenges in translation.
I think that's an awesome question, and the answer isn't necessarily so obvious. So it's certainly true that people like yourself who are used to looking at very high quality images in the darkened reading room, they have very specific ideas about what they want to see. Images that look like what you trained on, that have enough features and contrast to be able to make an unambiguous identification of a disease that you're looking for or change in pathology. At the same time, there is kind of an emerging idea that, well, taking a model of the stethoscope or other kind of low resolution tools, if you can get, a single voxel or some soft number, a few number of voxels in the field of view, but they either are yes or no for a particular question, those kind of tools can be used as well. I think about like diffusion tensor imaging, right? Or high B value DWI. The images don't look very good classically, right, at high B value, but they have tremendous diagnostic, well, I should ask you if they have tremendous diagnostic utility, because, well, for several reasons. They're telling you about other things that are going on, and you have the high resolution, registration image. So in the case of way back in my lab, we operate at 6.5 millitesla, right? The hyperfine instrument is 10 times higher. That's practically high field for us. So that's 64 millitesla. We're at 6.5 millitesla, and standard of care is 1.5 Tesla or 3 Tesla. And so the images in my lab historically are not high resolution. They're like 2.5 millimeter in plane. And yes, it's absolutely true that radiologists say, can you do better? And then we push the hardware, we push the physics. Starting a few years ago, my postdoc Bo Zhu rethought the whole way that we could deal with processing data as it comes off the scanner, rethinking like, well, what noise is fundamental and what noise can be kind of eliminated using deep and machine learning approaches. And that started a whole field. I would say it probably wouldn't have happened in our group if we didn't spend so much of our time dealing with moderately low quality images at ultra low magnetic field, right? So I don't know if I've answered your question, but what do you say to the radiologist when they say, can you do better? Well, it comes down to a conversation about what do you need? What do you feel like you need? What do you really need, right? And what are the key features? Like you could sort of do this mental, principal component analysis. What are the key features that you need to make the decisions for triage? Is this triage that we're talking about? Is this post-surgical margin analysis? Is this serial neuroimaging where you're looking at volumetric changes? I think the answers are complex and involved.
Yeah, definitely. I mean, I think one of the really cool things about the type of research you've done and many people working in this sort of translational sphere is pushing the envelope of what's sort of possible, sort of thinking beyond the box, because as physicians, I do think that we tend to be very conservative in our practice patterns.
Right.
It's all about evidence-based medicine, but how do you have evidence for some tool that will work if you've never actually deployed it before? It becomes a chicken and egg problem.
Yeah,
So,
that's a really good point. That's a super good point. And so right, if I said to you, okay, Susie, we now have an MRI. Let's pick on MRI. We have an MRI device that's the size of this calculator, right? And its resolution is okay, but you can take it with you. It's safe, right? And now you can start looking at things that maybe you've never looked at before, and so then that information has to go into your decision-making skills. And as you said, it's chicken and egg. Like, we have to do studies. We have to motivate clinical partners to say, this is worth trying, and devote time and resources to it. Maybe that's the hardest thing, is that, it's hard developing, I'm focusing on hardware, but of course it's the same for algorithms. But it's somewhat hard, although we're fortunate here at the MGH that so many of our clinicians are clinician scientists and they're open to new ideas. But then it's that next step where we say, okay, we're going to add your technology to our IRB. We're going to find the time and the resources to like put it into patient care. We don't, of course, want to overburden our patients. So how do you find the balance? And so I want to ask you, really, like, how do you resolve that point? You have a new sequence that is going to be really useful. You haven't demonstrated clinically that it's necessarily useful. You've done it maybe in vitro, or you've done it in animals, and you've done it, in phantoms. How do you make that decision?
yeah, no, I mean, in that regard, I think that the environment that has been established at the Martinos Center, with sort of all these interdisciplinary labs, people with different backgrounds and perspectives, as you're saying, working side by side, that's all really benefited this pathway. I mean, I think one example that really, I think, proved to be more valuable than we even envisioned was the whole fast imaging kind of translation that we started with Cowan Setzenpop, Larry Wald's group back in like 5 years ago. And I think it's really through a partnership between some very interested individuals on the clinical as well as on the technical sides, as you mentioned, to adopt the technology. So like John Conklin, who's a colleague of mine working in ED radiology, he's super interested in trying to actually demonstrate the practical utility of these fast imaging techniques, because you have a vision that it can be used to help patients be imaged faster so that doctors can get the diagnoses faster. And then we have scientists like Steve Colley, who are really dedicated and very responsive to understanding what it is that we need as the radiologists to be able, so sort of meeting each other halfway. And then also the neurologists and neurosurgeons, other referring providers picking up on the value of this. So so in fact, like, we've been able to deploy these sort of fast imaging techniques on a very practical level. We're using them in most of our protocols now on the clinical side. And that's just one example, I think, of. I think one of the real keys here was that in working on the translation is having the idea that if you can make the technology good enough that it will satisfy sort of the basic requirements of whatever it is that your referring providers need. So in ICU, maybe just trying to diagnose hemorrhage versus stroke, then then at least if you can get it to that stage, then they can take it and then try to test it out and really figure out what is the niche that it'll fit in. And then they'll come back to you and say, well, I like this, but this part doesn't work so well. How can you help me fix it?
Right. So fast imaging, that's a really good example, because as a physicist, and of course, watching all the fast imaging, watching all of you work on fast imaging, to me, that seems like a no-brainer. Like, oh yeah, that's going to be better. And it was interesting as an observer, because I wasn't involved in that project, to see, you really actually had to convince people on the clinical side, some people, that that's going to matter. Because, there's standard protocols, there's standard ways we do things. It takes a finite amount of time to get someone in and out of the scanner. Where does the advantage, lie? And so it's kind of an uphill battle. It can be, but I think to your point about, clinicians being conservative, they're conservative for a reason, right? And the standard of care is the standard of care because it's been proven out. And so it's interesting. And that conversation, I love that iterative conversation that goes on once the thing gets deployed. We're seeing this with some of our work with AutoMap for trying to improve the quality of high B-value clinical data. And it's just great to see like, oh yeah, this is good, this isn't good. You know, once you get to that stage, it's great because everybody is enthusiastic.
Totally, yeah. And I agree that here at MGH, we're really privileged and fortunate.
Oh,
to
absolutely, absolutely.
You know, clinicians who are really interested and open-minded about adopting new technology. So I think we were very fortunate in neuroradiology to have you know, experts on an MRI like Schaefer, Otto Rappolino, just be very open-minded about this, but then also trying to set some clinical standards so that we, you know, we're not trying to cut corners, but we're actually trying to make it match diagnostic quality.
Right, that makes a lot of sense. I see that a question from Chris Lindgren. It's quite interesting. I'm just going to bring it up, saying they love the idea that neuroimaging can be more prevalent in diagnoses, clinical trials, et cetera. So portable MRI leading to sort of more accessibility. And so what I want your opinion on is, we're talking about not just with portable MRI, but there are other approaches as well that are historically radiological, right? MRI, ultrasound, optical imaging, you know, they're sort of typically, that would be in your discipline. And now, you know, when you move the scanner away from the controlled access radiology suite and maybe into specialty care physicians' offices and things, that's a different kind of you know, hurdle, right? A different kind of, I guess. So I'm asking, I guess, about cultural changes. You know, I wasn't around. I mean, I was very young when you know, head CT came out, and then MRI came out, and you know, maybe Bruce can reflect on some of those things. But as these new tools change and they change workflow, I'd love to know kind of, what do you see as, like, how does one encourage that? How does one not get, you know, we all tend to get kind of cloistered. Like if someone in chemistry starts doing some physics stuff, I get a little cranky about it. And so like, if you see the neurologists doing radiology, you know, to pick on you, you know, how do you feel about that? How do you manage those kind of things? How do you imagine those things might work?
Yeah, I mean, for me, I really feel like you know, the ability to collaborate comes about when you see not the threats that come about from people's sort of but also the opportunities and what their specific expertise can bring. So, I mean, I would say, I mean, just as an example with the portable MRI in the neuro ICU, I don't think the radiologists would necessarily be able to execute a translational project of that magnitude as effectively as the doctors who are, you know, taking care of those patients. On the other hand, I have the confidence that if they ever had, you know, questions about or uncertainties diagnostically about what the imaging is showing, they'll come to us. And
that's a really good point.
Yeah, in that regard, I do think that everyone has something to contribute. It's really important to have this open mindset that you're confident in what you have to offer, and you also respect what other people have to give. So we may be very privileged here. I think I'm just picking on one example, but I think we work really well with the neurologists and in that regard.
Yeah, that makes a lot of sense to me. And I would say that has been, you know, the key feature of what I see at the Martinos Center. You know, from the scientist side, everyone tends to work together. And then the clinical collaborators, again, it's a very open conversation. Yeah. That makes a lot of sense.
No, that's super cool.
So actually, if I could ask a question, guys.
Sure.
So you talk about the importance of keeping a open mindset, and you know, sort of building sort of lines of communication. What are good ways to do that? Maybe especially in instances where those don't already exist.
Yeah, that's a good question. You know, again, like on the physics side, we just publish our stuff and like maybe it gets read, maybe it doesn't get read. That approach doesn't work so good in this space. So I will say that we have tried and been somewhat successful trying to get our academic work more into out of more specialty journals and into more general journals. You know, the Natures of Science, the Science Translational Medicine, these kinds of things, because then people see it and people get enthusiastic. That's just from a sort of purely academic publishing, you know, perspective. Certainly, things like the Brain Map seminar series and things like that at the center, it's changed a bit with so many things being virtual. You know, running into someone down the hall. That is a real kind of mainstay of kind of operational things at the Martinos Center, where like you're always running into. So like I used to see Susie in the high field scanner across the hall from me doing all sorts of interesting things, and you say, hey, what are you doing? What is that thing? And then you go back into the lab and you think, well, that's interesting. I wonder if either I can help or I can, I don't want to say steal, borrow that idea or something from that idea from my own work. So there's a lot of communication that happens, at least at our center. Now, over at the MGH, you know, you're all busy, and so how do those things happen? Is it like grand rounds and hanging out, or what's the mechanism?
I mean, I think grand rounds definitely that kind of forum, you know, where you just have people come together from different schools. So I would say more opportunities for people to come together and interact. It could be virtual. I like in person too, because it's very, you know, it's just the spontaneity is there. You can just, there's also, I think, various societies that are dedicated to trying to bring people together. So I know Matt and we're both involved in this International Society for Magnetic Resonance in Medicine, but I think that people who founded this society, I think Bruce Rosen might be one of those people. I think they had this real vision for trying to bring together people who understand medicine and also understand the technology to really talk and try to drive the field forward.
You know, that's interesting that you bring up the ISMRM, because I remember back in the 90s when I was doing physics, when I went to my first ISMRM and I was told by my advisor, oh yeah, it's an interesting place. It's like, I don't exactly remember the details of what he said, but like half clinicians and half physicists. And I thought, wow, that sounds amazing. You know, really weird. And like language will have to sort of get figured out, but amazing. And you're right. You learn a lot. One learns a lot at those kinds of things and about what are the important problems. So yeah, those meetings, getting together, big picture, you know, kinds of things are really valuable.
Yeah, I mean, Gary, you've raised a really good point though, that it's easy to become siloed in like even an institution like MGH, because we're sort of located in different campuses. And I would say that the field in general, I mean, medicine, technology, they're sort of going in different directions. I mean, it's just easier to become kind of to get down your own rabbit hole and chase some technology in isolation, because it requires so much expertise to do that. And similarly on the medical side, that you see subspecialization much more being the norm these days. And so the amount of knowledge that you have to build up and training you have to go through, it may be kind of an adverse force toward these types of collaborations. So yeah, I'm glad to see Paul Weavers is here. So he's asking, do you see people interacting who are only there because they now see the technology making the leap to a product? I expect you've had all different types of reactions to having this.
Boy, that's funny. So okay, we work on a lot of different things in my lab, and they're all many of them are in various stages of this pipeline. But talking particularly about low field MRI or ultra low field MRI as where the work started being useful to anybody. So yes, there's kind of an existence proof that happened when people started to see the work coming out of my lab and thinking it was interesting. And now that it exists, yes, there are people getting all excited about it. So I will say in the past, in the distant past, so we're talking 10, 15 years ago, I did have conversations with people who knew a lot about MRI, industrial people, who basically said, we've looked at low field MRI, it's not a thing, we're not interested. And as a physicist, of course, like I was undeterred and I kept going. And I tell that story not because, haha, we prevailed, but I think it's actually more telling. Those people I talked to were right in a sense. They came to the conclusion, which is correct, that low field MRI scanners will not outperform high field MRI scanners in metrics like signal to noise per unit time or image quality per unit time, whatever it is, right? Those are facts. But I think translation, and in this case in particular, is not necessarily about taking a thing we already have and maybe making it cheaper and smaller. That happens, and that's great when that happens. But I think in the case of the portable MRI story, it's about leveraging the utility of this incredible physics success story that is magnetic resonance imaging, and using it to do additional things, right? Not to replace the 1.5 and 3 Tesla scanners, but to, primarily because of safety, secondarily because of cost, take the MRI scanner and bring it in places where it could never have been, right? And so this complementary approach, it's not zero sum, right? Many of the companies were thinking it's zero sum. Oh, if we develop low cost, we cut off our arms, we no longer sell expensive machines, right? No, it's not zero sum. It's allowing people to do things that they couldn't do before. And I think about, I think I've said this analogy to Bruce before. So I was born in 1970. In 1970, you couldn't sell, a little 2-seater car that maybe got 100 miles per gallon to anybody, because, well, people wanted big cars and gas was cheap, right? And no way would that little car, replace the big family sedan. Well, in 2021 here in Cambridge, right? If that car is priced right, it's easier to park, it gets good gas mileage, it has a good environmental impact, and it can complement the larger vehicle that you use for, say, family vacations, right? So it's this idea that there are different tools for different things, and that's how it is. We don't use a Phillips screwdriver, to unscrew a flathead screw. Similarly, you won't necessarily use portable MRI to look for, epileptic lesions, which is a task that you typically do at 3T or higher. But you won't necessarily use a 7T scanner. You won't use a 7T scanner at the bedside in the neuro ICU looking at ventilated patients. So that's a long answer.
Actually, you touched upon some points that help address another question, which I'll read for you. In the preclinical space, we saw that lower field systems produced perfectly fine images, but once a user started looking at comparable research applications and publications, they quickly shifted back to conventional higher field systems in order to be relevant. To be successful clinically, is low field MRI going to compete with existing MR applications where low field is fine, or other cheaper, quote unquote, cheaper imaging modalities like ultrasound or planar X-ray?
So I love ultrasound. I love low cost, right? Those things are all great. Again, I don't want to say compete, because I think, and we'll get Susie's take on this, more information is generally better. But I would say it's a very valid question, doing low field MRI in the laboratory versus taking it out into the field and seeing what happens. And that's precisely why me and my collaborators and other people using the technology do clinical studies and publish them in peer-reviewed journals. So we showed last year in JAMA Neurology use cases for low field bedside neuroimaging in ventilated COVID cases down at Yale, New Haven Hospital. And then just this year, we published a paper in Nature Communications, MGH and Yale collaborators, looking at hemorrhage and evaluating it against a standard of care. And the standard of care may be CT, it may be high field MR. And the question is exactly right. You can't assume that just because something works in my beautiful sunlit laboratory, that it will work, when you're rushing around and there's ventilators and all these things. And that's why we do peer-reviewed science. So I think that's it. We don't know. We don't know, at least I don't know a priori. I would never assume, maybe in my younger naive days, I would say, oh, I'm doing medical things in my lab and they'll be fine out in the field. but now that I've matured, I would never assume that. These things always need to be tested. They always need to be validated by people like Susie, who has a foot in both worlds as a scientist and a clinician, and then of course with the subspecialties as well. Susie, I would love to know your
yeah, definitely. I mean, yeah, I mean, I think the other aspect of the portable MRI story is just one example. But yeah, the other angle that I would take on translational science is that it's a two-way street, right? So yeah, definitely bringing it into the portable MRI into the clinic, letting people try it out, just seeing what the use cases would be. I think that's already a huge advance. But then it'll also, I think, inspire people back in the lab to think about other ways that you could re-engineer your MRI scanner. And I think there's this whole trend now toward thinking about changing the paradigm of MRI, that it's not just about like the system as a whole. It has to be in this way. You have this huge magnetic field, you have these coils, but that how could you engineer specific aspects of the system to be good enough or good for a specific tailored problem? And I think there's, I mean, there's endless possibilities in terms of thinking about that, in terms of what kind of clinical problems, scientific problems you could address by, you know, taking the MRI scanner apart, trying to engineer and optimize certain aspects for the kind of information you'd like to gain.
You mentioned good enough, and I think good enough is really, that's a very powerful phrase, because in every application, good enough changes, right? Again, if you're looking at focal cortical dysplasia, it's very, very different from making a decision, hemorrhage, you know, or not. And so that kind of thinking does absolutely enable all sorts of people to do incredible ideas, you know, to answer those specific questions. You know, it's not a one size fits all. I mean, historically, right, MRI machines very expensive. They take a lot of hospital real estate. And so you're gonna like try to do as many things as you can on them. And once they are there, studies can be performed on them. And again, you know, people keep focusing on what else can you do with this amazing food processor, you know, or
yes, exactly. It's exactly.
Right? And you find oh, look, I can use it to do this and that. But then you can also say, yeah, but if I had just a regular paring knife, you know, I could actually do the same thing. I can't do all of those other things. I can't sous vide or whatever, you know, with a paring knife, but I can, you know, make my pie. And so then I think we're at a very exciting time in terms of radiological science, that we can start thinking about purpose-built scanners, technologies, you know, where the clinicians drive us to invent.
Yeah.
And again, that feedback loop is really very, very valuable. I don't know the history of diffusion MRI, but I certainly know about diffusion MRI in the diffusion NMR in the materials world and MRI in the materials world, but I don't know the history of how it translated into clinical practice. And I'm sure that story, though, is an interesting one. You know, where some physical chemists and physicists said, look, we can like study all of this stuff, and clinicians who were used to looking at or thinking of images as pictures, right, would suddenly now have this change in paradigm. So yeah, there's precedent for this kind of stuff.
Yeah, definitely. Yeah, and again, I think it's getting it into the hands of people who would use it to just try it out. I mean, to some degree, it is sort of like running an experiment with a new tool, but this time it's in patients. And I mean, you don't want to think about it that way, but it sort of is. You need to do that in order to see if there's going to be utility to these new tools, and it drives the whole field forward.
Hey guys, fantastic discussion. I wonder if I could jump in with a question. I'll start by saying, Susie, while I was in fact at the first SMR meeting, it was as a first-year graduate student, so I cannot take any credit. I'm old, but maybe not quite that old. I do remember the meeting though. It was a good one. And just a fantastic discussion. And the question about the diffusion, someday let's bring Ken in discussion. that I have a little bit more direct memory of, but we'll have that discussion elsewhere. I wanted to bring up a slightly different point. As both of you have mentioned, we are very fortunate here at the MGH because we have clinician scientists, surrounding us. And so when you look at the Martinos Center, when I see colleagues like Brian Edlow and Daphne Holt and Randy Golub and on and on and on, I mean, they are as much a part of the Martinos Center as you two are, independent of department, and that's fantastic. But there are times when we create new ideas. It's a new tool, it's a new contrast, it's a new physiologic measure, where we need to reach out beyond the clinicians that kind of also live at the bleeding edge, the way we do, to folks whose, principal job is patient care. And while they may have, some academic aspirations, really they're busy clinicians. That's most of what they want to do. And I know that there are challenges especially for our PhD scientists, not kind of understanding the clinical world quite the same way our clinical colleagues do. The clinical colleagues don't understand our language, right? There's that language barrier. And there's also, if you will, some kind of political differences, if you will, between the cultures of the two communities. What advice can you give, especially our, PhD investigators that are listening here, to developing, kind of healthy, productive, and balanced relationships with the clinicians? What are their expectations? How are they different from, say, our own expectations? How do we balance that and then, really begin to expand out the range of people that we can collaborate with?
Yeah, no, that's a really good question, Bruce. And it's actually something that I'm struggling with now, because as a radiologist, I see a lot of trainees really interested in research. I think they're at this stage in their careers where the sky's the limit. They have all these possibilities in terms of what they could do clinically, potentially academically in research, but they're also very busy. They have a lot of responsibilities. So, I mean, I would say time, if that's at all possible to carve out, that is, I think, one of the most valuable resources that we can put in the hands of our clinicians. Time to meet and have these kinds of conversations with scientists. Appreciate also that they have priorities for clinical care, that you have to, there are certain parameters and constraints within. So as just one example with the fast imaging and translation, boy, there are a lot of times when you're starting out here at the Martinos Center running it on just volunteers. And then I would be like, well, where are the images? There's no images. And then I'd be able to call somebody across the street and be like, can you guys come over here and look at the scanner? Because there's nothing coming up. But now when this happens in the hospital environment, the stakes are so much higher. When you have a technologist calling you, or basically the technologist saying, we don't know why the images are not showing up, and we had to restart the whole scanner. I think that is a very, difficult problem to overcome. And I do have to credit, it's everyone at MG. It's just not just the physicians, the clinicians, the scientists. It's also our technologists, everybody, the nurses, everybody who's involved in patient care. I think getting that kernel of important, and I think people do get that if you frame it in the right way, that we're doing this to help you put the patients through faster, so you don't have to torture them in the scanner, have them repeat things multiple times when they're clearly not going to tolerate it. I think once they get that, they're on board and they're willing to go with you. But it's a hard nut to crack. I agree.
Yeah, and Matt, kind of wearing your physics hat, how do you reach out to clinicians that may not know the technology, but they know a disease that you believe your technology may be relevant for, and how do you nurture that relationship?
I would say medical student research rotations have been really valuable for us, because we get people into, we cross-pollinate, right? They come in and they spend a little time with us, and then they go back out, and our name spreads, and people kind of have a sense, so that a couple years later, when I'm reaching out, when I ask you, hey, who's a person who does X, Y, and Z, and you say, oh, talk to this clinician, they kind of know who we are. I have found actually that generally, maybe because I'm very persistent, or maybe because when I email people, they think I'm you because of our names. But I have yet to have clinicians who I essentially cold call, be anything other than enthusiastic. I mean, of course they have their schedules, but people always seem to find time for a meeting, even if it's at 6:30 in the morning or 11 o'clock at night. And I think that that's, broadly speaking, our reputation as a center and the kinds of people who are doing patient care at MGH. So
we are certainly privileged in that regard. But I think your advice of persistence is very important, as Susie was saying, understanding the kind of clinical imperatives that our clinicians are under. There's a reason why there's so much conversation about physician burnout these days, because they really are overloaded, especially in the kind of COVID recovery period. Another reason why you need to stay persistent. But in the end, we are fortunate clinicians stay at the Mass General, typically not because they can get paid more than other places, but because of what's going on around us. So with that persistence and a little bit of effort to reach out to them, in general, people are interested. And if you nurture that relationship, it can be valuable. The one thing that I've learned kind of the hard way, in some of the early experiences I had, say, with our dynamic susceptibility contrast, is that providing the clinicians feedback on what we see, whether the experiment worked or not, especially when it's on their precious patients, is really important. I would go back and we'd be screwing around with our algorithms and, knocking our heads trying to think about what it was. And they just wanted to know, did it work? Did you take a picture? What can you tell me, if anything? It took me a little while to realize, unlike my fellow physicists who might understand, if I saw a patient, I need to write and communicate that to the physician that referred it right away and let them know what we can, and keep giving them feedback to nurture that. But with that in mind, people are interested, and that persistence and effort tends to pay off.
And I would add to that, Bruce, also on the front end, I found like doing my homework ahead of time, before I go bother these people, at least trying to understand the language and sort of like, kind of alpha testing the pitch on people at our center is very, very helpful, right? Because you want to be concise and accurate and not just kind of, rambling. So
that's a super good point.
Yeah.
Well, thank you all. Thank you, Matt. Thank you, Susie, and thank you, Bruce, for joining. It's been a fantastic discussion. Really, really quite amazing. So thank you so much.
Great. Thank you.
I guess with that, we will say thanks to everyone for joining, and have a great weekend.